Again, still working on looking at these audio output transformers, or audio transformers. My tablet here that I'm using to do the videos likes to stop on its own, and I don't know why. So occasionally I'm talking away and nothing's being recorded. So that just happened. So I'm just starting it up again. You must have missed a little bit of what I was doing. So I determined this is a choke coil. This is a center tapped transformer. This is probably the transformer I'm after. And the actual audio output transformer that drives the speakers is mounted right on this speaker. There it is there. And there's no other transformers other than the big power transformer. So this has got to be it. So that's a good thing. Now what I want to do is on the secondary side, look at the resistance across it. Oh, that might be quite easy to do because the leads are quite visible. I need something easy to do. Something positive here. So, okay, so here's a one wire. And it's going right here. And that's a, I don't think that's a 37. Okay, we're just ignoring that fact for a minute. It seems to be going to the wrong type of tube. No, that's a 37. So that's a, so there we are. So this has got to be correct. That's one side. The other side is going over here. I think we're looking for 2,000 ohms. Is it? 2,000 ohms, fairly clearly marked. So here we go. Uh-oh. Look at that. Put up on a 20 megohm scale. This is bad news here. Charging up a capacitor. .7 megohms. Why would you get a reading like that? 1.7 megohms. Oh, there is another connection off there. So there's another current path for my meter to take aside from the winding of that transformer. I didn't notice that. Well, there's a capacitor in the circuit. Okay, assuming the capacitor is not shorted, and it probably isn't shorted, then there shouldn't be any flow of current through there. Oh, what a headache. There's this this switch here, which may affect the readings. Let's see. That's the tone control. It may affect the readings. Let's see what happened here. Doesn't look like it, does it? 1.6 again. Switch it down to 20K. Because I start doubting everything about what I'm doing when this stuff starts happening. I mean, that's a good thing. You know, it's definitely over 20K. It's really 1.6 megohms. Mm-hmm. Be better off checking this, I guess, with voltage on. Now I see the output of that transformer goes directly, it goes directly to this tube, And the other wire goes directly to that tube. That's the other 37 in the can. Now how do you explain that? The other side does go to another 37, but on the way it should pass through 2 resistors and past a couple of capacitors. Wow. That's certainly not what's happening there. Now there's a couple more comments about this. First of all, I'm looking at this as the schematic. You know, is it really right? This may not be the right schematic. So that's not terribly helpful, is it? If that's the case. And when I was analyzing the schematic, and I made a video of my conclusions, and I think I comment somewhere that I'm sure all my conclusions are wrong. Well, I thought about it a little more afterwards, and certainly in the video where I'm analyzing the schematic and my comment, I have some comments around how it is this thing plays in this kind of condition. And I make a few deductions about how a signal is actually coming from the front end of the radio and managing to get into the output. And I realized afterwards that the signal has to be detected to produce an output. So where that's happening exactly in here, I don't know. None of it's making too much sense to me. So maybe this really is the wrong schematic. I guess we should spend a little bit of time verifying that, so there's no doubt about it. Lots of time here. And another mysterious thing on this schematic is this dotted line here. I really don't know what they mean by that, a dotted line. Does that mean it might be there? Doesn't make sense to me at all, so I don't know what they mean. So this is turning into a pretty tough job. I think I really need to switch it on and read the voltage coming into here, and you know, for sure this radio is similar to this schematic, if not identical. So why don't we do that? Because I don't think there's any reason I can't turn this radio on. Oops. And we'll take a shot at that. Okay, just a quick little safety check. Make sure there's no cats in the wrong place. Okay, switch on. There we go. Put my meter on the right scale here. Wake it up. First thing we'll do is we'll check B+. Verify the meter's working. There we are. You can hear a little sound out of the speaker. B+ is there. So now I should be able to find the B+ on either side of this, if it is what I think it is. So I'm just going to clip one lead of my meter so I don't have to hold it onto anything. And let's see. Okay, one side should be here. 128. The other side, 0. Well, that's a really, really bad sign. No voltage on the other side of that, so that proves one of my theories. Unless there's another wire coming out of it. Darn it. I see a wire in the area there. I can't quite see where it's going. I put more light on the subject. Yeah. Yeah, there's only 2 wires coming. Oh, wait a minute. Guess what? Guess what? That makes more sense. I followed the wrong wire. Hallelujah. I love it when I find my mistakes here. This is the wire I should be following. This wire is not coming out of here, now that I put better light on it. So this guy, he's going, looks like here. And there I got 154. Hey, that's good. Well, you know, I'm totally wrong about what this transformer is. At least I'm proving that that winding is good. So we got 128 on one side, 154 on this side. Ah, man, you gotta have an awful lot of doubt about everything, especially when things don't work out. You know what I was told by one of my instructors years ago? Sorry about the light there. He held up a voltmeter in front of the class, and he said, "You know what the problem is with these things?" And this was in college, and we're all looking at each other. Well, not really. What are you getting at, teacher? He said, "The problem with these voltmeters is they'll always give you a reading." And so we all kind of looked at each other and thought, well, what's the problem with that? And then we realized you can easily be fooled. You get a reading and you accept it. Meanwhile, your probe's on the wrong contact, you've misinterpreted something else, but you've got a reading. And the worst thing, of course, is the reading is in the ballpark of what you expect. And it's just so easy to get misled doing these kinds of things. At least that's what I find. Well, maybe we can go a little further now. So we know there's a voltage coming through that transformer here. What I need to do now is move down the line to here and try to verify these guys. So we'll spend just a moment on that. I think it's going to be these resistors that are all, there's a whole bunch of them tucked in here, dog bone resistors, a whole bunch of them. Yeah, I don't think I'm going to bore you with me trying to sort that out. I'll do that off camera. And I'll catch up with you in a little bit. See if I've gotten anywhere, but I'm not having good feelings about this radio. That's all for now. Bye.